Hi, welcome to part 5 of the video series about work and energy. In all previous parts, we were dealing with the works done by individual forces. But in real life, there are usually more than one force doing work on an object. In this video, we will learn how to calculate the total or net work done on an object by all the forces applied on it. Let's consider the diagram displayed on the screen. The object is being moved by force F, which shifts its position by delta x across a rough horizontal surface. At first glance, it appears that F is the only force acting on this object. Drawing a free body diagram will allow us to see all the forces acting on it. While force F makes an angle with the horizontal and pulls the object to the right, force of gravity pulls it downward. Then there is the normal force applied by the surface on the object. Finally, the friction force is trying to keep the object from moving. Each of these forces can do some work on an object on its own. Adding all of the works provides the total amount of work done on the object. There are two methods for calculating total or net work. The first, as previously indicated, is adding all of the individual works. While using this method, we can ignore the works done by forces acting perpendicular to the displacement, since their works are equal to 0. The second option is to first calculate the net force and then use it to calculate the net work. Let's solve a simple example to show the use of each of these methods. Calculate the net work done on the object in the figure if the object moves 5 meters to the right. The diagram illustrates all of the necessary information. We can begin answering the question by drawing a free body diagram. The forces acting on this object are the applied force acting to the right, the force of gravity acting downwards, the normal force acting upwards, and the friction force opposing the motion and acting to the left. Since gravitational force and the normal force are acting at a right angle to the displacement, works done by these two forces are equal to 0. As a result, we can ignore them in our calculations. The net work done on the object is the sum of the works done by friction force and applied force. Work of friction is calculated as the products of friction force, displacement, and cosine theta. For this example, friction force is equal to the coefficient of friction multiplied by the object's mass and gravitational acceleration. Coefficient of friction is 0.2, mass of the object is 4 kilograms, gravitational acceleration is 9.8 meters per second square, the displacement is 5 meters, and the angle is, as usual, 180 degrees. Work done by friction force is equal to minus 39.2 joules. The work done by the applied force is equal to the product of the applied force, displacement, and cosine theta. The force is 30 newtons, the displacement is 5 meters, and the angle is 0 degrees, because the force is acting in the direction of the displacement. The work done by the applied force is equal to 150 joules. We will add these two values to calculate the net work. Minus 39.2 plus 150 equals 110.8 joules. Let us now look at the second way of calculating the total work. We already have the free body diagram from the first method. Because the object does not move along the vertical axis, the normal force and force of gravity act in opposite directions and have equal magnitudes. As a result, the net force acting on the object equals the difference between the applied force and the friction force. Kinetic friction force can be calculated as the product of coefficient of friction and the normal force. In this case, mass multiplied by gravitational acceleration. Coefficient of friction is 0.2, mass of the object is 4 kilograms, and gravitational acceleration is 9.8 meters per second square. Friction force is equal to 7.84 newtons, and it is acting to the left, opposite to the direction of motion. Net force is equal to 30 minus 7.84, which is equal to 22.16 newtons to the right. We can now write down the formula of work. Net work is equal to net force multiplied by displacement multiplied by the cosine of theta. Theta is the angle between the net force and displacement. They both are pointing to the right, hence the angle between them is equal to 0. Net work is equal to 110.8 joules. We learned how to calculate the net work done on an object by 2 or more forces in this video. In the following video, we will start learning about energy. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.